Merriams and Websters of Python. I'm Professor John Gallagher, and I hope you're ready to get your dictionary on because we are about to learn how to use dictionaries in CircuitPython. We'll first create and use a dictionary in the REPL, and then we'll create a dictionary that allows us to look up a note based on a note name. And we'll modify the code that we wrote in our previous lesson so that we can play tunes from Happy Birthday to Beethoven. Let's look up some big learning. So most programming languages have dictionaries. They're considered fast and powerful ways to look up data. Now in CircuitPython, a dictionary is an unordered collection of key value pairs. See down here, we have pairs of Olympic cities and the year they hosted the Olympics. The key is the string holding the city name. The value is the number holding the year hosted. Now each key has to be unique, no repeats. Now you define the keys with curly braces around all the key value pairs. The keys and values are separated by colons, and the pairs are separated by commas. See here, city colon year, comma, city colon year, comma, city colon year, comma, city colon year, and everything is surrounded by curly braces. Now while dictionaries are defined using curly braces, values are retrieved by passing a key between the square brackets. So down here, if we use the dictionary name Summer Olympics, and between the square brackets we pass in the key, the city named Rio, that's a string so it's in between double quotes, we get back 2016, a number, the value associated with that key. And that's the year Rio hosted the Olympics. And you can use variables too. Here we define a variable named Olympic City, setting it to Los Angeles. And when we use this statement, we print Los Angeles, the contents of the variable Olympic City, is host of the 2028, that's retrieved by passing Olympic City, Los Angeles, into the dictionary Summer Olympics, Olympics. So now let's try this out in the REPL. So I'm in PyCharm, I'm going to get into the terminal, I'm going to expand the screen so I take up as much space as I can, and I'm going to get into TO, and I'm going to get into the REPL by pressing any key. Now, I find it helpful to remind students how lists work before we contrast them with dictionaries. So let's create a list called countries. We'll set this equal to, and in between square brackets, the string UK, comma, Canada, comma, Burkina Faso. Now to access an element in the list, we just give the list's name, countries, and between square brackets, we pass in the index value of the list. Remember, lists are zero indexed, so if we pass in a 0, we get back UK. And if we say country, square brackets 2, we get Burkina Faso. Now let's create another list called capitals, and we'll set this equal to, in between square brackets, the strings London, comma, Ottawa, comma, Ouagadougou. So now if I want to get the capital of Burkina Faso, well, let's see. I can up arrow and go to countries, bracket 2, and change countries to capitals, press return, and I get Ouagadougou. Well, that's cool, but sometimes what you really want to do is you want to look up one term based on another term. For example, I might want to pass in a country's name and find out the capital. Well, that's where dictionaries can be a big help. Friends, let us create a dictionary. We'll call this capital_cities and set this equal to, and remember, dictionaries are in between curly braces. And inside the curly braces, we put in our key value pairs. Those keys and values are separated by colons, and the pairs are separated by commas. So our first key value pair is the string UK, colon, London, comma. The second pair will be Canada, colon, Ottawa, comma. And the third pair will be Burkina Faso, colon, Ouagadougou. Make sure you close that curly. So you see we have a dictionary named Capital Cities with 3 key value pairs, UK, London, Canada, Ottawa, and Burkina Faso, Ouagadougou. And then on the next line, if we want to get the capital of Canada, this is not the way to do it. To use our dictionary, we can say capital_cities, the name of the dictionary, and in between square brackets, we'll pass in the string Canada, and this gives us Ottawa. Nice. Capital cities in brackets Burkina Faso gives us Ouagadougou. Now what about if we do something like this? Capital cities, and in between brackets, the string USA. We haven't defined that yet. Press return. Don't! We get key error USA, which means there's no key USA in our dictionary, capital cities. Now, there are a bunch of different ways we could catch this error. We could use a try statement, but also there's a special feature in dictionaries in Python where we could say the dictionary name, capital_cities, dot, and use the get method. The first thing we pass in is the key we'd like to get, comma, and after that, in case we don't get a value, we list what should be passed back. So here we'll say data unavailable, press return, and instead of getting an error that would crash our code, we get data unavailable. Now what if I up arrow and change my statement to get UK instead of USA, press return, we get the correct value, London, because UK is a key in our dictionary capital cities. Nice. And we can have lots of different kinds of dictionaries. For example, our first dictionary at Capital Cities was 2 strings, but we can put numbers in here as well, and that's where we can create a cool dictionary for our notes. Here's a little sampler. We could say notes equals, and in between curly braces, the string C, colon 262, which is the frequency value for the note C, comma, and we could add as many key value pairs as we want in here. For example, D, colon 294, close curlies. And if we access notes and pass in the string D and press return, we're going to get 294, which would be super handy if we want to play notes. Note C gives us 262, looking good. So now let's close the terminal and apply what we just learned in our code. Now the code that I have on screen is pico PWMnotes.py. This is the code that we used at the end of our last lesson when we learned to play notes using PWM and frequency values. We'll start here and we'll make some modifications. Now the first thing I'm going to do is I'm going to highlight and delete this list notes, and I'm going to replace it with a dictionary. And why don't we kick it up a notch? We'll add a notes dictionary with 2 octaves instead of 1 this time. So dictionaries are like a list, but we pass in the key to get the value. So we'll say notes equals, we'll give it the same name, and remember, in between curlies. And so it's easy to read, I'm going to put my key value pairs on separate lines. And I'm going to get all musical-like and refer to our octaves as either octave 4 or octave 5. So the first string is going to be C4, that's middle C on a piano, colon 262. And remember to put a comma after each key value pair to separate it from the other one, get to a new line. Then C sharp 4, colon 277. D4 colon 294, D sharp 4 colon 311, E4 colon 330, F4 colon 349, F sharp 4 colon 370, G4 colon 392, G sharp 4 colon 415, A4 colon 440, A sharp colon 466, and B4 colon 494. Make sure you got the commas after each of these key value pairs, and let me put in a comment down below that says octave 5, which is above the middle C, so octave 4 is the middle C octave. And to make things easier, I'm going to highlight all 12 notes on my first octave, copy them, and here's a pro tip for you if you didn't know it already. You can option click on multiple lines to put cursors on multiple lines. Now since I want to delete all of these 4s and replace them with 5s, I'm going to click just behind the 4 on each of these 12 lines, then backspace once, type a 5, and look at that, 5 goes across all 12 lines. Cool. Then let's replace our number. So C5 is 523, C sharp 5, 554, D5, 587, D sharp 5, 622, E5, 659, F5, 698, F sharp 5, 740, G5, 784, G sharp 5, 831, A5, 880, A sharp 5, 932, and B5, 988. And now that we got our dictionary set up, let's create a function that can play a note from the dictionary key. And we use that to pass in a note name. Let's define a function below our other 2 functions. We'll say def, we'll call this play underscore note, and in between the parentheses, we'll pass in what we call note underscore name colon. Now in the next line, we'll put in a comment that says play a note name rather than the frequency. So if note underscore name is in notes colon, that checks first to make sure that we've got a valid key. We'll say play a tone notes, passing in between square bracket note underscore name, comma, tone underscore duration. That's a value that we set up above in our previous lesson, currently at 0.2 seconds. And we want to play a tiny rest after each note, so we'll say play underscore a underscore rest, again a function we wrote last lesson, and we're going to pass in rest underscore duration, a value we set up in our last lesson at 0.01. Now outdented down below, we'll say else colon. If we passed in a note name that we don't have in our dictionary, on the next line we want to print out F string, and in between double quotes, note, in between curlies, note underscore name, not found, exclamation point. Now friends, let us play some notes, and I'm going to play some crazy notes, and I'm going to show you another important issue about dictionaries in CircuitPython. First, I'm going to delete the for loop and a bit of the comment in here, so now the comment reads, go through all the notes in the notes dictionary, and watch what I'm going to do here. I'm going to say for note in notes colon, and then play underscore note passing in note. Now this is going to cause us some problems. Let's open up the terminal. We're still in the REPL. Remember, to get out of the REPL, you type Control D. And what the backflip, that did not at all sound like the notes in the order that we set them up in. And that is the case, my friend, because remember, on our previous slide we showed you, but we mentioned it very quickly, dictionaries in CircuitPython are unordered collections of key value pairs. Now by unordered we mean if you iterate through them, you're not guaranteed to get the dictionaries in the order that you enter them in. Gadzooks! Now, in modern versions of Python, you actually will find that the dictionaries are in the order that they were entered in. That's still a fairly recent Python update. There are a lot of older versions of Python out there, and CircuitPython, as of the time I'm recording this, has not updated to use that additional feature where dictionaries are ordered, but that's okay. We've got a workaround. I'm going to create a list of strings called C major scale and set this equal to, between square brackets, C4, D4, E4, F4, G4, A4, B4, C5. Then in our for loop, instead of iterating through notes, we're going to iterate through C major scale. We'll use each of these strings one at a time to look up the value in our dictionary, so let's save this. And oh, much better! Our dictionary of notes and frequencies is working. So now that we got this working, let's play another tune. I'm going to put a play arrest in here and pass in 1 second. I'm going to create a list called Twinkle and set this equal to, and in between square brackets, C4, C4, G4, G4, A4, A4, G4, F4, F4, E4, E4, D4, D4, C4. I think you know what tune this is going to be, my friends. For note in Twinkle colon, let's play note note. You know what, above this I'm going to print out play Twinkle Twinkle Little Star. Save that bad boy, let's hear what you got. And haha, Twinkle Twinkle Little Star. Nice! Well, actually, not as nice as it could be. Let's modify our play note function so that we can also pass in a rest, so that we can have a pause in between the different bars of Twinkle Twinkle. So in our function play note, just before we have our else, why don't we add an elif? We'll say note underscore name, double equal sign, and we'll pass in all caps rest, colon. That means instead of passing in a note name, we can pass in a rest, and then we can just call play a rest, passing in the tone duration. And this is how you'd use this. So after the first bar with the G4 note here, this doesn't have to be in a separate line, but I'll put it on a separate line because it's easy to read. I'll just pass in all caps rest with a comma afterward. Now let's save and listen to the mellifluousness. Call the Grammys. Now that we got the rest in it, it sounds spectacular. Now, if we're really going to play musical notes, we know that musical notes actually last at different periods of time. There are whole notes, quarter notes, half notes. So why don't we modify our play note function so that we can pass in a duration to play those notes, instead of having to use our fixed duration. Now, before we make any changes, I'm going to highlight these two tunes that we were playing, the Twinkle Twinkle, all the way through the C scale, and I'm going to command / to comment them out just so that they don't repeat again. And we're going to modify our play note function with a default value. So we're going to add a second parameter, but if we don't pass in a value for that second parameter, then we'll tell our code what to use by default. Follow me. So in our play note function, inside the parentheses, after the note name parameter, we're going to say comma and duration. Now this adds a second parameter that we can pass in, and we're calling this duration inside the function. Nothing new here. We've done this before. But now I'm going to add an equal sign and then follow this with a variable named tone underscore duration. What this means is that if we pass in a value, call it duration inside the function, but if we don't pass in a value, then take our value tone underscore duration. We defined that earlier in our program. It's currently set to 0.2 seconds, and we'll use the value in tone duration for our duration variable. So cool. I'll put a comment after this saying if no duration is passed, use tone underscore duration as the duration. Then inside this function, when we call play a tone, instead of passing in tone underscore duration, we'll just pass in duration. And also in the elif for rest, we'll also pass in duration instead of tone duration. And that's it. And you know what? I changed my mind. I'm going to remove the comments in these tunes below because I want to show you that these calls call play note with only one parameter, not two parameters, and they should work. They'll just use the tone underscore duration as that constant second parameter. But let's add a new tune that has the duration values for its notes. Before I do that, I'll call play a rest and pass in 1.0 for a 1 second rest. And this new tune is going to be Happy Birthday. You know that song. As the youngsters say, it slaps. So here's what we're going to do. Just like our other tunes, we're going to create another list. We'll call this one happy underscore birthday and set this equal to and in between square brackets. And I'll put this on multiple lines so it's easy to read. Instead of passing in a single value for the string of the note we want to play, we're going to pass in a tuple. We'll just put in parentheses, and inside that will include both parameters that we want to pass to play note. The first one will be the string for the note to play, and the second will be the duration that that note should be played. So between parens, the first value will be C4, 0.2, comma, followed by another tuple, C4, comma, 0.1. Make sure you got a comma after this because we got more notes coming. And in the song, this will be happy. Then on the next line, I'll put the tuple in between parens, D4, comma, 0.3, comma. This is going to be birth. Then between parens, C4, comma, 0.3, comma, day. Parens F4, comma, 0.3, comma, 2. Between parens, E4, comma, 0.6, U. Apologies for my terrible singing. But now watch how we're going to play and call this. So down below we're going to use a for loop, and because each value in happy birthday is a tuple, let's decompose those two values. We can put each of them in separate variables, and we'll do it like this. For note, comma, duration. So the first value of the tuple goes into note, the second value of the tuple goes into duration, and we'll say in happy underscore birthday colon. So that'll iterate through all the elements of happy birthday, decompose the two value tuple into two separate variables, and down below we'll call play underscore note, passing in note comma duration. Let's save this and strike up the band. Well, if your birthday wish was mad code skills, you just got your wish. Now what if you don't know the notes and durations for songs? Well, let's ask AI for some help. I'm going to copy all of my CircuitPython code, then head over to my browser. I've got Claude.ai up, and I'll ask old Claude, hey, I've written the following CircuitPython code. Can you create a list for me named Ode to Joy that includes tuples to play Beethoven's Ode to Joy? I'll paste in my code, click on that up arrow to set Claude to work, and look at how speedy Claude is. It spits out an answer for us. Why don't we highlight and copy this code? Return to PyCharm. Down below, I'll once again call play a rest and pass in 1.0 for a little bit of a rest. And I'll say print Ode to Joy. Paste in the Claude code. And I could type this in here, but why don't I head up instead and copy the happy birthday for loop. Then head down below the Claude code and paste that in. And just change happy birthday to Ode to Joy. Save this. Let's give a listen. And you might have noticed, if you know this tune, there was a bit of a glitch in here, and this underscores the sometimes unreliability of AI. It says note G3 not found. Even though we pasted in all of our code, Claude didn't look at all our code and recognize that we did not define a G3 note in our notes dictionary. Shame on you, Claude. If we scroll up, we can see the problem in our notes dictionary. So we've got all of these notes in the 4th octave, the 5th octave. We've got nothing with 3 in here. Claude didn't recognize that. Again, sometimes AI can be surprising in how quick it offers answers, but sometimes it gives you bad code. This is an example. It'd be curious if you run this example at a time when Claude is updated and it gives you the correct answer. If it does, let me know in the comments. I'm sure you can use AI or search on the internet to figure out how to fix this on your own if you'd like. For now, I'm going to head up here and I'm going to change the top comment to dictionarynotes.py, copy this and use this as the name, saving it to our CircuitPython school folder, and closing that outermost tab. Well, sonorous CircuitPythonistas, in this big learning lesson, we learned how to use dictionaries. We tried some dictionaries in the REPL, and we coded up a dictionary for 2 octaves of musical notes. We played a bunch of tunes. We noted that the order values of a dictionary aren't reliable and may change. We modified a function to include default values so that our function could accept 1 or 2 parameters, and we used AI, noting some problems, to help us play us some Beethoven. Ring on with those skills, Pythonista. You can keep a prof happy by dropping some goodness in the comments, and always continue to hack.